Hello, discrete math fans. So in this section, we're going to discuss two classical theorems in mathematics. The first one is going to involve irrational numbers. Now, we've talked a lot about rational numbers. Remember, those are real numbers that can be expressed as the ratio of integers. But the question that we haven't answered yet is, are there any real numbers that cannot be expressed as the ratio of integers? That is to say, are there any irrational numbers at all? Now there are, but we haven't proven this yet. Now there's lots of irrational numbers, and there are numbers that you're familiar with. You know, things like square root of 3, pi, e, log base 2 of 5. You've run into all of these. But the fact that they're irrational requires proof. All right, so what we're going to do is we'll prove that square root of 3 is irrational. First, let's state and prove a lemma. Remember that a lemma is a small theorem that helps us to prove a main theorem. All right, so in this case, the lemma that we're going to prove is that for all integers m, if m squared is divisible by 3, then m is divisible by 3. All right, so let's do a proof by contrapositive. So what we're going to do is suppose that m is not divisible by 3. And we're going to try to conclude then that m squared is not divisible by 3. So knowing that m is not divisible by 3 tells us from the quotient remainder theorem that m can be written as 3q plus r for some q and r in the integers. But ordinarily the remainder can be either 0, 1, or 2 since we're dividing by 3. But we're supposing that m is not divisible by 3, so the case where r equals 0 can't happen. That means there's only two possibilities here for r. R has to be either 1 or 2. All right, so the first case, when r is equal to 1. Then we just do a little bit of algebra involving m squared. So we can say that m squared is equal to 3q plus 1 quantity squared. And then we multiply all that out. And it's not too hard to see that we can factor out a 3, and we have a remainder. So m squared is written as 3 times some integer plus 1, and so that tells us that m squared is not divisible by 3. In the second case, we're going to say that r is equal to 2. Then we'll do the same kind of thing. We take m squared, and write it as 3q plus 2 quantity squared, multiply all that out, and factor out a 3. And when we do that, again, there's a leftover 1, so that proves then that m squared is not divisible by 3. So that proves our lemma, so that if we have a number whose square is divisible by 3, then the number is divisible by 3. Let's move on to the main proof. We're going to now show that square root of 3 is irrational. So that's the theorem. Our theorem is that square root of 3 is irrational. All right, so this is going to be a proof by contradiction. We're going to assume, for the sake of contradiction, that square root of 3 is rational. All right, so let's write down what that means. It means that there exist integers m and n, so that square root of 3 is equal to m over n. Now, we can go ahead and assume that m and n have no common factors. If they did, we could just cancel them out. All right, so there's no factors that are in common with both of them. This is an important assumption that we're going to need later on. All right, let's square both sides, and we'll get 3 is equal to m squared over n squared. Or we could just write this as 3n squared equals m squared. Now that tells us that m squared is divisible by 3, because on the left-hand side there's a factor of 3 over there. And our lemma then tells us that m is divisible by 3. Now, since m is divisible by 3, there exists an integer k such that m is equal to 3 times k. All right, let's plug that in. So we'll get m squared is equal to 3k quantity squared, and that equals 9k squared. But remember that m squared was supposed to equal to 3n squared. And so we'll divide by 3 That is, we're going to divide both sides of this equation by 3, and we'll get n squared is equal to 3k squared. All right, what does that tell us? That tells us that n squared is divisible by 3, and our lemma then tells us that n is divisible by 3. All right, so we know that both m and n are divisible by 3, and that means they both have a common factor of 3. Remember, we made an assumption that the m and the n have no common factors. We can go ahead and assume that because anytime we have a fraction, we could just cancel them if necessary. Since we've arrived at a contradiction, that means our original assumption, which was that square root of 3 is rational, cannot be true. And therefore, we can conclude now that square root of 3 is irrational. This really is a classical proof and something that you should definitely learn as you're going through your studies in mathematics. Just this concept of being able to prove that something is irrational in this method, very important. Okay, that's all for now.